All right, so welcome back to another one. So still on the elimination method. So there's the reason why this elimination method is kind of annoying with linear systems is because you can have your coefficients, so the numbers in front of your x and your y, either integers, decimals, or fractions. And sure, you can cover that all in one video. It'll be kind of long, or just most of the time people just give one or a couple of examples. I wanted to spend as much as I can. So if you want to see the elimination method kind of from the beginning, I'm going to post links. So the first one was basically assuming that you have integer coefficients. You know, you should start there. Okay, so I'll put a link up above to that. Now, once you finish kind of watching that one, it's going to give you a good sense on the elimination method what to do when your coefficients are integers. All right, so your coefficients are basically the numbers that are in front of your variables. Now, if it happens that you have your coefficients as decimals, so decimals are actually not bad to get rid of because we multiply by powers of 10. But if you like, you can watch the video. Okay, I'll put a link up above to that. All right, so to specifically that, okay, if you're dealing with that problem. Now, if you have fractions like you see here, okay, then I'm going to show you, how to go about and getting rid of kind of fractions per se, and then using the elimination method to continue. So when you have fractions, you can do quite a bit, all right? You can definitely get rid of fractions entirely if you want. And doing that, you can basically take, okay, the denominators of each of the lines. So for example, the 4 and the 5. And then you can get rid of those fractions, okay, in front of that x and the y. Entirely by simply just multiplying by a common denominator between them. So if you multiply by a common denominator, you're going to get rid of those fractions in front of your x and your y. Now, the number that you see there, 1 over 10, that might still remain, okay, so depending on what you multiply by, but at least you won't have to deal with anything, okay, in front of your variables. So let's do that, okay? So that's kind of method number one. So I'm going to go through these. So this is not going to be kind of an easy short video, okay? Because there's different ways of doing it. So method one is, okay, multiply. So you multiply by your lowest common denominator, all right, to get rid of these, okay? So for example, if you take 4 and 5, all right, so I'm going to take that first line. Now, the lowest common denominator between 4 and 5 is 20. Now, if you've forgotten how to do lowest common denominator, okay, I'm going to put a link up above, all right, to the video on that. So I'm going to assume that you know how to do that. So 20 is the lowest common denominator, okay, between those two. So what happens is you can take the line, so this entire line, and so I'm going to take this, so copy, let's paste it. And then I can change this now line. So instead of this, okay, so this line would change because if I multiply by 20, so notice 4 goes into 20 5 times. So 5 times 3 is going to be 15x. Then it's going to be minus, and then you have 20, okay, and then the 5 goes into 20 4 times. So 4 times 1 is 4. So notice you have that. And then you have 20 times 1 over 10. Now, in this case, it happens that 10 goes into 22 times. So notice that your coefficients now are no longer fractions. They're just basically integers, which is the original problem, okay, that I asked you to watch. Now, of course, this is just one line. So this is the first line. So now you have to go ahead and do that with the second line. So now in the second line, I have 6 and 8, all right? So what is the lowest common denominator between those? I'm going to change the color here. So this one. So between 6 and 8, the lowest common denominator, which one would it be? Now it turns out, okay, that it's going to be 24. So we're going to have to multiply by 24. Again, if you've forgotten, watch that video on finding the lowest common denominator. So if I do this, So let me take this, copy it, paste it. All right. Okay, I'm going to change this up. So now this line is, so 24 times 1 over 6. Well, 6 goes into 24 4 times. So this is going to be 4x. Plus, now 24, okay, times 3 over 8. Well, 8 goes into 24 3 times. And then 3 times 3 is 9. So this is 9y. And then you have 24, okay, times the negative 4 over 3 on the right-hand side. Well, 3 goes into 24. And it goes in 8 times. So 8 times 4 is going to be 32. So negative 32. So now notice what you've done is you've gotten rid of your fractions. Now, you may still have a fraction on the right-hand side. It just so happened in this case we didn't. But at least your coefficients are just integers. And then once they're integers, then you can basically do exactly the same thing as we did in the integer video. All right? So now the problem becomes that you have new, okay, so fx minus 4y is equal to 2, and then you have 4x plus 9y is equal to negative 32. All right? So it's easier to work with. Now, is that the only method to do it? So now you can go ahead and solve. Again, I'm not going to solve it this time around. You guys can solve it. I've already put the videos up with the integers, so you can go back to the beginning, okay, of this video. Or maybe I'll put a kind of a little note where you can go back and then find the link, all right, where I point out to it. That's for integer, because here's everything is integers. So that's method 1 to get rid of fractions. All right, so that's 1. Now, ultimately, what we're trying to do is we're trying to use the elimination method, right? We want to be able to eliminate, okay, one of the variables. So here is method number 2 that you can use. Now, I don't really like providing numerous methods, but because this is just a general video, I'll do it, and then you can see which one works better. Now, and if you continue doing these problems, okay, so, you know, as long as you have more tools, you can start applying them. But ultimately, if you're just starting this, pick a method, get good at it, and only then start looking at other methods. All right, so I'm going to take this problem back up again. So let me copy this. So copy, bring it down, paste it. So that was my original problem, right? Now, let's say instead of doing what I did above, which is get rid of fractions and just work with integers, now what I would want to be able to do is I actually would want to get rid of, okay, the variable entirely. So I'll pick x or I'll pick y. Again, the elimination method, it doesn't matter. So let me get rid of, for example, the x. All right, I'm going to try to get rid of the x, so eliminate it, like using the elimination method. In order to do that, these two coefficients have to be the same. So this one and this one, they have to be the same. Now, but they're fractions, right? So how do you make them the same, right? Or what's kind of one way to do it? So one of the easier ways to do it is, you know, in fractions, you may remember reciprocals. So a reciprocal, so for example, if I have 3 over 4, the reciprocal of this is 4 over 3. Okay? And then the reciprocal of 1 over 6, the reciprocal is 6 over 1. Now, why are these reciprocals useful? Because I can take the reciprocal and I can multiply the entire line by the reciprocal. And when you do that, your coefficient will become 1. All right, so let's do that. Okay, so this is method number 2, multiplying by reciprocals. All right, so basically that's what we're going to do. Reciprocals. Okay, so, okay, let me bring these down again. Copy, paste. Okay, let me show you what happens. So if you take this, okay, and then multiply by reciprocal, so 4 over 3, and then this one is going to be multiplied by 6 over 1. So what do I get in this case? So if I do that, then this particular line, now it's not going to be all nice and pretty, but it does the job. So notice the 4 over 3 times 3 over 4, well, that's just going to give you x, right? Because that's going to be 1x. So you're going to have x, okay, and then minus. Now here, okay, you're going to have 4 over 3 times 1 over 5. So that's a little annoying because we're going to get 4 over 15 y equals 2. And now you have 4 over 3 times 1 over 10. All right. So 4, okay, notice the 4 and the 10. Well, I can reduce that because 2 goes into 4 and 2 goes into 10. Okay, so that's going to be 2 and 5 at the bottom. All right. So let me, just so that I'm not complicated and complicating things for you here. So let me just show you this way. All right. So this is the 4 and the 10. I can reduce that to 2 over 5. All right. So now if I reduce that to 2 over 5, then on top I'm going to get 2 because it's 2 times 1. And then 3 times 5 is 15. So it's 2 over 15. All right. So at least this way you saw what happened. 2 over 15. So that's my first line. My second line that I have, so this line right here, I'm going to be multiplying this, then times that, and then times that. Well, 6 over 1 times 1 over 6 is 1. So again, I get x. And that was the point. The point was just to get rid of and have the same coefficient. All right. Now you have 6. Okay, so now it's going to be 6 over 1 times 3 over 8. Let me do that here. Okay, so now the 6 and the 8. So 2 goes into both. So this is going to be this. And that's going to turn out to be 9 over 4. So that's going to be plus 9 over 4y equals. And then I have 6 over 1 times the negative 4 over 3. So notice the 3 goes into the 6 2 times. So this is just going to be minus 8 over 1, which is just minus 8. Okay. Now, once you have done that, once you multiply by the reciprocal, now the problem is, well, you can get rid of and you can eliminate your x. So by subtracting, notice that x minus x is gone. So what you're going to have is you're going to have negative 4 over 15 y minus 9 over 4y equals 2 over 15 minus, okay, this negative 8. Okay, and now you only have y. And now you might say, oh my gosh, I have so many fractions here, I got to deal with it. Yes. I mean, I didn't say it's going to be easy, okay, but this method, yes, you might have to deal with fractions. And then you might have to find common denominators. If you can use a calculator, then it's so much faster. But up to this point, the goal was to eliminate one of the variables. So now you can solve for y. You can solve for y. Okay? And now once you solve for y, then you can substitute back in and solve for your x. And that's the goal. So this video I made, all right, it's basically a 3-part video. And that's why I was showing you the links in the beginning. Okay, so now in terms of solving this whole thing, I can go ahead and do it. I'm going to cheat here a little bit. I'm going to use a calculator. So I have negative 4, all right, over 15. And then I have minus, this is 9 over 4 equals, so that's going to be, so notice that's an ugly number, 151 over 60, y equals, and then my other one, so I have 2 over 15 minus, in brackets, they're negative 8. So notice that's 122 over 15. All right. So now I can solve for for y. So now y is equal to this. All right. So I can take, this is now back to solving. So negative 151 and 60, so that the 60 cancels and that cancels, just so that I can solve. I have to do that to both sides. Negative 151. All right, so I have that. And now again, so I can use 122 all over 15. and then times, and this was 60. So 60 all over negative 151. So my answer is a terrible answer, but so be it. But that's your y. Now you can change that to decimal if need be, but if they want you to work with fractions, again, then that's what you have. Now the beauty actually here is, because when you're in school, sometimes like these numbers just work out perfectly, right? Most of the time, because the teachers kind of set up the questions that way. This one I just out of the blue put it up there. So the number isn't nice. Now once you have this y, then you will take the y and you will substitute it back into the, let's say, original equation and find your x. And yeah, it's annoying. It's a lot of work, but that's how you would use the elimination method, okay, if you wanted to. And this was by multiplying by the reciprocal. So as you can see, it doesn't always nicely work. It nicely works to eliminate here, so to eliminate these x's, but it may not nicely work out the rest of the question. All right? So that's method number 2 for working with fractions. All right? Now, here is the last method, okay, that I want to just show you. And the last method that we have, so I'm going to copy this, copy. And you can choose whichever one you want to use for the questions you run into. So we used either getting rid of fractions, right, entirely, or, okay, we got rid of, okay, by multiplying by the reciprocal. Okay, so that was, 2 things that we've done. Now, okay, so the last one is we basically will do something similar, all right, like multiplying by the reciprocals, okay, if we wanted to or not. Okay, so this last example that we have, okay, is basically, so what we're going to do is we're going to pick a coefficient we want to eliminate. Okay, so whatever coefficient we have. So I eliminated x in the previous one. Let me eliminate y. So my coefficient, so I have 1 over 5, and then I have 3 over 8. Okay, so that's what I have. Now, our goal is to make them the same, right? Our goal is to make them the same. If, okay, for instance, you were working with integers, all right? So if you were working with integers, so let me separate this into 2 things. So let's imagine, okay, that I was working and those coefficients were only 1 and 3, all right? So they were only 1 and 3. So what would we have done? Well, we would have been basically trying to find the lowest common multiple between 1 and 3 so that we can eliminate it, just as we did with the integers. So I'm using exactly the same method there. So what is the lowest common multiple between 1 and 3? Well, it's 3. And in order to do that, I would have to multiply this by 3 and then multiply this by 1. Okay? So that's between this and this. Okay, so the lowest common multiple is basically 3. Okay, so that's between the top ones. Now, what if now, okay, because it's fraction, I don't have just the top, I also have the bottom. Okay, this one, 5 and 8. So what I ask is now, okay, between 5 and 8, what is the lowest common multiple? All right, between these 2 numbers. Okay, and it turns out, in this case, unfortunately, it's 40. All right, you can't really get away from that. Okay, so it's going to be 40. So now, how to get to 40? Well, it's going to be multiplying this by 8 and then multiplying this by 5. So here, this right here is going to be our coefficient that we want to be able to create. And you create it by finding the lowest common multiple between your numerators, and you find your lowest common multiple between your denominators, or like finding like a lowest common denominator. All right, and you have that. And now you multiply each line, okay, by the corresponding values. So notice, okay, the 1 over 5, you're going to have to multiply by 3 over 8, okay? So you're going to have to multiply this by 3 over 8. So that came from here, because that's the 1 over 5. And now the other line, which is going to be multiplied by 1 and by 5. So 1 over 5. So this is now going to be multiplied by 1 over 5. Again, why am I doing this? The reason is because I want the coefficients, now in this case I chose y, to be the same. I want those to be the same so that I can add or subtract the two lines and eliminate my y and then go ahead and solve. So now notice what would happen. So if I did this, so I have 3 over 8, okay, so notice what's going to happen here. So 3 over 8, okay, I'm going to kind of skip this one because I want to show you that the y's line up. So 3 over 8 times 1 over 5 is going to be 3 over 40. Hint, hint, hint. Okay, lowest common denominator, 3 over 40. And then the bottom one, which is 1 over 5 times 3 over 8, all right, is going to be again 3 over 40, which is exactly what we wanted. So once these coefficients are now the same, now of course you have to still multiply 3 over 8 times 3 over 4, and then 3 over 8 times 1 over 10, okay? And do the same thing at the bottom by multiplying by 1 over 5 the entire line. And then in this case, you know, you can add or subtract. In this case, you're going to be adding the two lines and you will eliminate y. From there, you do what you like, okay? From there, it's always the same. So those are the 3 methods I wanted to provide to you. You pick one, which one is the best one. Is it the first one? Is it the second one? Is it the third one? It will honestly depend on the questions, okay, unfortunately. So in the beginning where you're doing this, just stick to one. Learn it very, very well, okay? It may not be the best way for all of them, but it will work and you're going to get good at it. So pick one of the methods and then use it. So it's a long video for this, but I always find that when people do these videos, okay, so what happens is, and it looks like my camera's out of focus here, what's going on? Let me refocus it, there you go. So what happens is that in these videos, you know, people are basically giving you 1 or 2 examples and not really showing you the whole thing, which I have done too. I screwed up like that as well. But at least this way I thought about it and I gave you these entire 3 videos, okay? Integers, decimals, and fractions, how to deal with them. The rest is practice. That's it. Sorry, student. A lot of work, but make sure you understand it. Once it starts clicking, okay, you can leave comments. You can send me comments. I'll try to reply. You know, you can go on 1mjourney.com and send me an email if you like, okay, if you have questions. Okay, we'll see you in future videos. Bye, Niner, or grade 10er.